Hello everyone, welcome back. The IIT Kanpur just dropped the sample papers for 2025, and let's look at like 2-3 questions of this paper and let's see how they've made it. So I reviewed it and I feel like it's a little bit advanced, a little bit Olympiad oriented, but it's a decent paper. So one second, let me just yeah. So let's get into it. So the first question, you would have pt of x as some quadratic, and yes, this is the whole equation, and we have been given these roots and we have been asked some questions about it. So when you so since I've just solved this, I'll just tell you what's going to happen in this paper. So first you need to find discriminant because it's asking for distinct roots and you need it to be greater than 0. And when you solve that, I believe the first option is correct and we need to find the false one. And similarly you can find using the quadratic formula that b is also correct, and this is obviously correct. If you put in this value here, you would clearly have that the discriminant would tend to 0 and alpha t would tend to beta t. So yeah, this would also be correct and this won't be correct. Okay, let's move on to the next one. So basically I'm not discussing this one because it was an easy one. What about this one? This one was a good question. Basically it was talking about like a square region, which was starting from 0 0 and 1 0 till n 0, and here 0 0 n, and here n comma n. So basically it was talking about the space, and it defined some lines L, like any xi yi joining xj yj in this area, with obviously xij to be integers less than equal to n, right? Because yeah, we want it in this region S. Okay, so it's asking us the probability that this line is a tangent to this particular circle with the radius this n times root 1 plus 1 minus 1 by root n square. So it's asking us the probability that it becomes a tangent to the circle. So for this question, first we need to actually put in some values that would help us a lot. So when I try to find p1, so then I'm talking about this square, which is 1 1 0 1 0 0 and 1 0, and when I take the radius, this shall be 1. So this should be the circle, and I would have this as a tangent and this as a tangent. So both of them are tangents to the circle. So two lines are tangents, and how many can I draw? I can draw 4 C2 lines, as there are 4 points and I need to choose 2 for a line. So I would have 2 upon 4 C2, which should be 1 by 3. So P of 1 is 1 by 3. What about P of 2? So for 2, when I find, I would have, so basically this is why I told you that it was kind of Olympiad oriented, was because when you compare this term 1 plus 1 minus 1 by root n square, you would find that except n is, like, if I take n greater than 1, obviously n belonging to natural, when I take that, I would have this number, like this whole quantity, to be slightly greater than this whole quantity. Let's say it's x, it should be slightly greater than 1, and n, so obviously the radius is this, so the radius is slightly better than it's slightly more than n. Okay, so for any n by n space, when I look, the radius would be slightly more than n, so it would become something like this. Obviously this would be root 2n, I don't know about that, but it would be across this, right? So since it's a little bit more than n, we can clearly see that there is no possible case for any line to become a tangent to this. Let me draw it again. so that it's a little bit clear, because this is just way too untidy. 1 second. Yeah, so this is some n comma n. So when I draw for any like any n, generalized n, I should get something like this. It may cut here, but no points are going to be such that we can make a tangent on this. Like all of them are gonna fall in and they are gonna make chords, so we are not going to get a tangent. So the probability that n tends to infinity, basically it's p1 is equal to 1 by 3, but p for I such that I is greater than equal to 2, we would have 0. It's just not going to be 1. What about the third one? Well, third one is talking about some ellipse omega with f1 and f2 foci, and yeah, pf1 intersects the circumference of the ellipse and is neither on the major axis. So yeah, it should be somewhere here, and it should intersect at some q, and then it should go through f2 because of the reflection property of ellipse, and same with this one, which is given to be r in the question. So we have been asked the perimeters of pf1 and pf2q, so we need to just break this up like this: f1q plus pf2r, sorry, my bad. So we have covered this with pf2q, right? So f2q plus pf2. So when I look closely, I can write this as pf1 plus pf2 plus qf1 plus qf2. Now note that p and q are both on the circumference of the ellipse, and for any such point I can say that ps plus ps dash is equal to 2a, right? So this should be 4a, and when I write this for the other triangle as well, I should get the same thing and they should be equal. So yeah, and same with this one. We there can be a case when the area of the triangles would be equal, and for D option we would have the two lines f1 f2 and qr are always parallel. That is absolutely wrong. So C is actually correct, because yes, they are bisected by f1 f2. You can check out the fourth one. I just don't like PNC much, so I'm not gonna go so deep into that. Moving forward, this is a very easy question. Just apply 1 minus tan square theta by 2 upon 1 plus tan square theta by 2. Just use this and you shall get it. Like, take this as fx maybe. I don't mind it. I think the answer for this one was okay. I think it's multi-correct, right? So I think this one was wrong, this one was correct, this one was also correct, and this one was correct. I think the answer was BCD. You can check out the official solutions as well. For this one, you just need to assume a few vectors for which this can be true. I think B was 100% true. This one is very easy. Like, this one was way too easy. I think this was mains level question. Like, just put z is equal to x plus iota y, and h of z would just be iota x minus y, and just to compare the options. It's just about mapping of functions, right? This one was kinda good. This one, I think this one was from a Chinese mathematical Olympiad. I don't remember. Yeah, you can easily try this one. This is just about putting values in. Like, this is not that hard. It's just a little bit of manipulation. And yeah, I think we'll just keep on going. I think this one was kind of irrelevant. From what I've heard from others, I haven't really tried all of the paper, let me be honest. I've tried till like question 8, I guess. I did not try the numerical value questions. So yeah, I think, yeah, if you want the solutions to this paper, I might put them on. So yeah, do like the video and comment if you want a whole solution for this. But I think yeah, it should be doable, and since the provisional keys are out, you can check the answers out as well. So yeah, thanks a lot for watching.